We're taping here. The first thing I want to point out here is you really need to get, like I said before, when you see x squared minus like 1 or 4 or 9 or some perfect square, you need to recognize that, hey, this is actually x minus 1 times x plus 1. And if you rewrite it, you're like, oh, okay, I got all these common things there. So I got 2 over x minus 1, x plus 1, minus 1 over x minus 1 equals 1 over x plus 1. So we're trying to figure out if we get the same thing that Liza got here. All right, so one of the things I'm definitely going to need to multiply by?
X minus 1.
X minus 1. So I'm going to do this individually now. Normally I put this whole thing in parentheses and I distribute, but I'm going to do it individually now just so you can see kind of, I don't know if that's throwing people off. So I'm definitely going to multiply everything by x minus 1, and I'm going to do this in steps. I'm not going to do it all at once, although you can definitely do it all at once and multiply both the x minus 1 and the x plus 1 at the same time. But I'm going to do it in steps here. So first one here, my first term here, what's going to be left over after my x minus 1's cancel?
1. Oh, the first one.
Yep.
2 over x plus 1.
2 over x plus 1. And I got to make sure I don't forget that minus. And what's going to be left there?
1.
Just the 1. And then over here, nothing changes, nothing cancels. So I got x minus 1 over x plus 1. All right, what's the only thing left to get rid of? X plus 1. And the only trick here is I've got to make sure I remember to multiply everything times the x plus 1. So we could have done this all in one step up at the top, but I'm just doing it in 2 steps because I don't know if maybe that's throwing people off a little bit. So I got 2, I got a minus. Now this is a place where some people are going to make a mistake. This is minus the x plus 1, so that minus is going to get distributed to both those. Some people are going to forget that, and they're going to end up with a minus x plus 1, and it's going to throw their answer off. And on the left side, those will cancel, and we're just left with x minus 1. All right, now we just got to do a little bit of algebra to get to the end here. So if I remember to distribute that negative, I got negative x minus 1 equals x minus 1. I can add x to both sides, and I'm going to finish my work over here. So I got a 1 on one side, the 2 minus 1. I got 2x minus 1. Add 1 to both sides, I get 2 equals 2x. Divide by 2, I get 1. Okay, so we got exactly the same thing that she got. Why does that answer not work? She plugs it back in, she says it doesn't work.
Because there's an x minus 1.
Yeah, up here, the x minus 1, if I plug that in there, 1 minus 1 is going to give me 1 over 0, and that's going to give me an error. So if I was actually graphing it, it'd probably be like an asymptote there. So that's just a restriction. So this is, once again, as far as an explanation here, the correct language here is there's an extraneous solution at x equals 1 because of x minus 1 in denominator of original problem. And if you don't go back and look at the original problem, or you don't go back and check, you're probably not going to notice that. Okay, I want to, before you do these next couple, I want to point something out. For number 2, if you look at that, it seems like you could just take the, multiply by 2x minus 4 on both sides, and also multiply by x minus 2 on both sides. And somebody want to tell me why that's more work than I need to do?
Because the 2x minus 4 is actually x minus 2.
Yeah, I can rewrite that as 2 times x minus 2. And you need to start looking for that. You need to see, anytime you look at the bottom, you need to figure out, is there something that I'll factor there that maybe there's a common factor that I only have to multiply through by once. Okay? What about in 3? Do I need to multiply everything by the x squared plus x minus 2, as well as the x plus 2, as well as the x minus 1?
No, the x plus 2 and the x minus 1 are x squared.
Yeah, in fact, that's probably a hint. When you get to those, you should look at those, and probably at least one of those 2 factors will be there. It's not always going to be both of them, but usually it is. And you have to be careful, because sometimes I'll actually think that it is, and I'll be wrong, because I'll be leading on. But that right there is definitely x plus 2 times x minus 1. So I'm just going to scratch that out and rewrite it that way. So that's important that when you start seeing those, you factor them and think about, okay, I don't have to multiply by everything. Some factors I have in common. And since we're talking about it, has anybody figured out the weird thing about number 1? There aren't going to be any solutions. Now, I did this wrong the first time I did it. I did this. I multiplied both sides by x plus 4. And then what I accidentally did is I got 6x plus 4 on this side equals 0, and I eventually got x equals negative 4, which is extraneous. But what happens with my x plus 4s over here? They actually cancel. It's easy to accidentally do 6 times x plus 4, but it's just 6, and I get equals 0, which we know is no real solutions. Okay?
You can tell anyways, because like if there's a number on top and it equals 0.
Right. You could reason through that one as well. And we talked about this yesterday. If you get something equals another number that's not the same number, that's a no real solutions. Whereas, what was it if we had like 2 equals 2?
All real numbers.
All real numbers. Okay, that's great. So try those.